10.3. Evaluate and graph logarithmic functions. So we know that exponential functions have the inverse functions. So when we try to find exponential function, inverse of exponential functions, first you rewrite, like for example, f of x is equal to 2 to the x power. We rewrite f of x with y, and then interchange with x and y, and now we have a problematic how to solve for y by itself. So that makes us create another operator, which is called the logarithmic functions, which is the inverse of the exponential functions. So what is the logarithmic functions? Is f of x equal to log of base a x. Okay. So this base can be changed depending on what exponential base is. The logarithm base can be changed also, right? To talk about inverse. And x has to be greater than 0. And not necessarily all the time, this will be just x. It could be x plus 3, x plus 4, 2x minus 3. So therefore, inside the logarithm, okay, inside the logarithm of functions, this is called the argument. Some textbook use this terminology, some textbook doesn't. So I'm going to use the argument. So later on, you can see that when I say argument of the logarithm, that is basically talking about what? The input part of the logarithm. So, okay. So when the argument is greater than 0 and the base is greater than 0 and then not equal to 1, because this is inverse of function, so the requirement from the exponential is still there, right? The base has, that's the requirement from the exponential part. So the base has to be greater than 0 and then not equal to 1. Then the logarithm equations can be rewritten as an exponential equivalent form. So that will become what? Here's the base. Here's the base. That's my argument. And then this is my argument. And then your y become what? The exponent of the base. So exponent. So in general, to keep it simple, log of base ax, that is basically equal to a number. What that number represent is the exponent of base a, which gives the value equal to the arguments. Okay, so then basically that's the interpretation. The logarithm expression is just a number. This entire logarithm is just a number. What does that number represent? Exponent of the base a, which gives you this argument value. So continuing this, to make sure we understand this, like, we need to try a couple of times until we got used to with this terminology. Okay, so what I just erased it, you need to repeat it over and over again. So now another definition that we want to talk about, the notation, is common logarithm. The common logarithm is basically talking about logarithm with base 10. So whenever the logarithm is base 10, you don't really need to write it down the base at all. So you can just say log of x. So it's automatically known that the logarithm has base 10. Another logarithm that we need to talk about is natural logarithm. That is with base e. So when you see that log of base e, this entire log of base e can be denoted as just ln. Okay, log of base e that basically represent ln of x. Okay? This log of base e represent ln. So the reason why we talk about these two logarithm function is because your calculator can be only compute by either base 10 or base e, unless you have a Casio calculator which allows you to put in a different basis. And later on, we're gonna have a formula to help you to compute, okay, a different basis. So right now, let's try to get used to with this logarithmic functions. So first, I want to convert the exponential expression into logarithmic expression equation. So example 1, if I say that 3 to the second power is equal to 9, then in terms of logarithm equations, equivalent one will be log of base 3, because the base of exponential and base of log will be the same. And we know that the entire logarithm with some argument right here, the entire logarithms is equal to exponent. So therefore, in this case, exponent is 2, and the argument will be what? 9. So log of base 3, the argument is 9, that is equal to the exponent 2. So notice that the entire expressions on the left hand side, the logarithm is equal to a number. That number represents the exponent of the base, give you the argument. Next, 1/3 to the x power is equal to 1 over 27. So when I rewrite this into exponential logarithmic equations, there will be log of base 1/3. Make sure you write the base in subscript, please, so that you will not mix up with your arguments. Okay? Log of 1/3, base 1/3. The argument is equal to the exponent, which is x. So what is my argument in this case? 1 over 27. Next, e to the x plus 1 is equal to 2. So in this case, my exponent is x plus 1, and then log of base e to the argument, in this case my argument is 2. And then to be more proper way of writing, whenever you say that log of base e, we will use the notations ln of 2 is equal to x plus 1. This will be the final answer. So try to get to used to it from here to there right away. Right? So this is a conversion from exponential to logarithm equations. Now the next will be converting from logarithmic equation into exponential form. So log of base 4, the argument 64 is equal to 3. So according to the definitions, base to the exponent is equal to the argument. So notice that 4 to the third power is 64, same, right? Example B, -2 is equal to log of 1 over 100. In this case, we don't have a base. That's basically talking about a common base, log of base 10. So base 10 to the -2 power, that is equal to the argument, which is 1 over 100. Lastly, ln of x plus 2 equal to 3. So you need to remember ln is log of base e. So in this case, my base will be e to the third power, that is equal to the argument, which is x plus 2. So these conversion is a must that you need to know, well, to continue evaluating, solving equations, so on and so forth. So next, we'll be evaluating the logarithmic expressions. So we want to find the exact value of logarithm without using calculator. Some of them can be computable by hand without using calculator. Some of them you cannot. Okay, so we will talk about that more later on. But in this sections, we are interested in using by hand only so far. So log of base 12, 144. So we know that this entire log of logarithm expressions will be equal to a number, but that number, the way that we have to think about is that number is basically the exponent of base 12, which will give me the result same as the arguments, which is 144. If I interpret it that way according to the definition, then we can basically see that we are solving for the exponential equation. So to solve for this exponential equation, we rewrite as the same base. 144 is 12 to the second power. So therefore, x must be equal to 2, which means the exponent is what? 2. This entire logarithm is basically equal to 2. So log of base 12, 144 is equal to a number 2. But that 2 is what? The exponent of base 12, which give me 144. Next, hopefully you get an idea of how to think about this logarithm. Right? So now it's log of base 4, but the argument is 2. So same thing, this entire log of base 4 argument 2 is equal to a number, which is, that number is base 4 to the x power, right? That number is exponent of base 4, which gives me the value equal to the argument 2. Now, I can rewrite this into 2 to the second power to the x power is equal to 2 to the first power. So 2 to the 2x is equal to 2 to the first power. This is basically the manipulation from the previous section, right? So now I can say that if the base are the same, the exponent must be the same. So my exponent is equal to 1/2. So think about it. 4 to the 1/2 power, that means what? Square root of 4, which is equal to 2. So therefore, log of base 4, argument 2, that is equal to 1/2. Lastly, log of base 2, and my argument is 1/32. So this logarithm basically represents a number, right? This entire logarithm represents a number. What is that number? That number is exponent of base 2, which will give me the answer 1/32. And we know that 32 can be rewritten as base 2. So this is 2 to the 5th power. And change it into numerator. So that will be 2 to the -5th power. Now I know that my exponent must be equal to -5. So log of base 2, the argument 1/32 is equal to the number -5, which is the exponent of base 2, right? That gives you the value 1/32. So this is the evaluations of a logarithm expressions without using calculator. And then next, we're gonna continue into graphing logarithmic equations.